I'm John Schrott, and this is On the Spot with IKM. Today we're going to be talking with one of our associates, Brian Roth. Brian leads our science and technology group here, and we want to talk a little bit about the nuances of designing BSL-3 laboratories. Now, Brian, maybe tell people what a BSL-3 really is.
Sure, John. Thanks for inviting me today. We want to talk a little bit about BSL-3 labs, but in the context of what a BSL-3 laboratory is. There are actually 4 categories of biosafety levels in laboratories. Biosafety level 3 is the next to the highest biosafety level. These levels are established by the Centers of Disease Control in their BMBL, biosafety for microbiological and biomedical laboratories. So they define the type of work that's being done in these laboratories, and they've set up the criteria for BSL 1 through 4. 4 is really for select agents and very dangerous materials. 3 is the next tier down from that.
So if I work in a BSL-3 lab, can I go in like this?
Generally, no. There is a certain amount of PPE required, personal protective equipment required to go into a BSL-3 environment. Again, the idea is to contain a highly infectious agent within the laboratory boundaries.
So what are some of the tools we use to make sure that's safe?
So there are very strict entrance requirements for a BSL-3 laboratory environment. The laboratory has to be secured, and security through card access or some other secure means. There are 2 doorways that must be automatically closing doors that have to be passed through in order for you to enter the actual BSL-3 environment. So physical security is a component. Keeping the qualified people, make sure only qualified people enter the laboratory space.
So a double door, so you're creating kind of an airlock. So air must be really important in BSL-3 design.
It is very important. In fact, the manual and the design requirements manual from NIH also specify inward acting airflow, so negative pressure in the BSL-3 environment at all times.
So inward acting air pressure, is that just another name for negative pressure?
It is, yes. The airflow needs to move from higher pressure space through the anteroom into the BSL-3. And even under emergency conditions, that airflow cannot be reversed. So typically we see mechanical systems on emergency power for that purpose.
And then oftentimes there's fume hoods, right, in these BSL-3 spaces.
Not so much fume hoods, but biosafety cabinets. So most of the time, biological specimens are manipulated inside a biosafety cabinet, which is HEPA filtered. It's for the protection of both the specimen and the worker who's manipulating the specimen.
So you have a lot of information, Brian, and I'm sure we could spend a lot more time talking about it, but I think our time right now is up. So until next time, this is On the Spot.